This week's kind of weird. We've got 3 B days and 1 A day for the week. That's unusual, but that's where we're at. So tomorrow's the only A day of the week. So tonight is parent-teacher conferences. Not that there's much to conference about at this point, but some parents may want to come up. So that is going on from 4:15 till 8 p.m. tonight. Virtual schools located in BHS. So we certainly welcome parents to come on. Okay, looking at Algebra 3. Again, I like to go to the grade screen because that's the easiest way. This just shows you all of the stuff, but it doesn't tell you when anything's due. This is not necessarily the best thing you use. The to-do list can get out of date or not let you know if something's already passed. So going here, September 11th is this Sunday. So these are the things that are due this week. We have a quiz over the first 2 lessons. So module 1 quiz, and I see some people have already turned that in. That's great. But if you haven't, it's not due for another week. So you're doing fine. A quiz. And then we have lessons 5 and 6, writing the equation of a line and comparing functions. So that's what we'll be looking at today, is just a summary of those 2 lessons. And then there's a lot of good stuff in those lessons. So whatever I present here in class is not a substitute for that. This is in addition to that to help you understand all this good stuff. But writing the equation of a line, I think it's only 6 pages. Yep, has some videos. Right there is a 52-second video. There's the questions of what you learn in the lesson. And we're going to talk about the different forms of linear equations. So, but think about it. Check your work. Another example. Remember, anything you see like this that has a link, you need to see what information's in there. Here's 4 steps to solve this equation. Learn more, writing the equation of a line with a point and a slope. So there's more information in there. So there's a lot of information just right here on page 2. So don't forget to check all of those things. But let me put up a piece of paper here and let's review what these lessons are talking about. So looking at lesson 5, we're talking about creating the equation of a line, like writing the equation of a line. And there's 3 different ways that we do that. 3 different ways. There's the one we're most familiar with is the point slope. The point slope of an equation, right? And that is I'm sorry, slope intercept is most common. We use slope intercept and point slope. And then the standard form. So slope intercept, of course, is the y equals mx plus b, where m is the slope and b is the intercept. That's what we're used to seeing. Point slope is where all we have is the slope and a point that is on the line. And in that case, we'd have y minus whatever the point is, the y coordinate of the point equals the slope times x minus whatever the x coordinate of his point. And that's when you have a slope and you have a point, x1, y1. Right. So when you have a slope, and that's kind of just a comma between them, a slope and a point, x1, y1, then you can write it in point slope. The standard equation of a line is ax plus by equals c. That one we generally can't just look at a line like on a graph and write it in standard. We generally have to write it like this first and then do a little bit of algebra to move the x on the other side and create the standard form. So we generally have to have one of these other forms first, and then we can derive the standard form from that. So let's look at that. You got to calculate the standard form. So let's say we have, let's say we just have 2 points. Okay, we don't have a slope at all. We've got 2 points. So let's give ourselves 2 points here. Let's say we're going to have the point 1, 2, and we're going to have the point -2, 5. So if we have 2 points, How can we get any one of these three? We want to write the equation of a line. We know if we have 2 points, we can make a line that goes through those 2 points, right? That's all we need is 2 points, and we can create a line. But how do we get any one of these when we only have 2 points? See if I can get y'all awake this morning. Put that in the chat. How are we gonna write an equation of a line with only 2 points? Where do we start? Anybody? Where do we start? I need some of that Jeopardy music to play there. What are we going to do? This we need a point and a slope and a point. This we need slope and an intercept. And this we don't know how to get from just points. All right, y'all totally lost today. It's going to be a long week for y'all. All right, we have an equation that we can derive the slope if we have 2 points. We take the y's, y2 minus y1, and put them over the difference of the x's, x2 minus x1. Right? We can derive the slope. So in this case, we can make either one of them y1 and x1. So we'll just say this is x1 on top, and this is x2. So y2 would be 5 minus y1, which would be 2. X2 is negative 2 minus 1. So we've got 5 minus 2 on top is 3. Negative 2 minus 1 is negative 3. So our slope is negative 1. That's the slope between these 2 points. So to write the equation of this line, the easiest thing to do with what we now have point and a slope. We have 2 points. We can pick either one. So let's just pick the first one. And so the equation of the line that passes through those 2 points is y minus, and we'll take the y coordinate, 2 equals the slope, negative 1 times x minus whatever the x is. So this is the equation of that line that will go through these points. This is the exact same line. If we choose the other point, y minus 5 equals negative 1, x minus a negative 2 means it'd be an x plus 2. These are the exact same line. We just wrote it in point slope, and we used both points. So we have the same line written with 2 different equations. We can convert this to slope intercept. Let's just take the second one. We just solve for y. So we have to simplify this. The first thing we have to do is parentheses, right? PEMDAS, don't forget order of operations. Y minus 5 equals negative 1 times x is negative x. Negative 1 times 2 is negative 2. We're almost there. Just need to solve for y. Add 5. Not a good 5. Y equals negative x plus 3. Okay. All 3 of these are the same line. Point slope, and slope intercept. We can write it in standard form by just moving the x to the same side as the y. So this gives us x plus y equals 3. And that is the same line. So all 3 of those ways, we can write the same line. We can write it in point slope, and we had 2 options since we had 2 points. We can write in slope intercept. We can write in standard form. Just by having 2 points, we just have to figure out what the slope is first. Right? If we have a graph, let me put a graph up on the screen. If we have a graph, Then for the slope, we just count, right? We got 2 points. We start in the point on the left, rise over run, right? Rise over run is the slope. So the rise from this point to this point, it rises 2, and then the run is 4, and they're both positive numbers. The 2 is going up, so it's a positive, and then your run is going right. So 2 over 4. So that means 1/2, right? 2 divided by 4. You put it as a fraction, the 2 over the 4. And so then here is point slope form of this line. They use the point -4, -3. See, the x is right here. That -4, it's x minus -4. It's y minus -3. And the slope of 1/2. Slope intercept form. We can look at the graph and write it in slope intercept form. We know the intercept is at -1. That's where it crosses the y-axis. The intercept's -1. And we know the slope is 1/2. So it's y equals 1/2 x minus 1. That's y equals mx plus b. And in standard form, we just have to move the x to their side. Now, what they've done here is got rid of the fraction. They just multiplied everything by 2. They didn't want to deal with the fraction. Standard form, we get rid of the fraction. So multiplying everything by 2, y becomes -2y.
Any questions about this?
And this becomes, and they got rid of the negative over here too, because let's do that one on paper just to show you what they're doing, because they didn't take that just simply equals 1/2 x minus 1. All right, let me put that on the paper here. So what they did is they subtracted the x to move it to the other side. So you got -1/2 x plus y equals -1. Well, that looks a little sloppy. Standard form, you kind of like that to be a whole number, and you like the x to be positive to starting out. So they multiplied by -2. -2 times 1/2 makes that a positive x, and 2 times 1/2 is just 1. Then you got -2y, and you got a +2. So that's how they got from this slope intercept to this standard equation, because they just cleaned it up. It's the same equation as this. They just cleaned it up by getting rid of the fraction and making the first variable a positive by multiplying by -2. But these are the same equation, just making that a little neater. Make it that a little neater. So, all right. Let's see. I think that's all the big stuff. Just a reminder, when you're studying all of this, I think it's on page 4 here. Let me get rid of this. Move this graph back over here for now. I think it's on page 4. Nope, it's on page 3 right here. Lesson summary. Most of the time, you'll be able to find the lesson summary. We have some of these lessons later that won't necessarily be as easy to find this way, but click on lesson summary, and this tells you everything we're learning in this lesson. There's the 3 forms: standard, slope, intercept, point, slope. X plus b, y equals c. Y equals mx plus b. And see, in the standard form, you want that x to be positive. That's why they multiply it by the -2 to make that a positive. And then the point slope with the y1, x1. See, it's got that x1, y1 point. And then it talks about you have to calculate the standard form that we talked about. So here's those 2 points that we were looking at. And so you can use that, and we can either go to slope intercept, y equals -x plus 3, or x plus y equals 3, which is what we did on paper. And then here is the graph that we just looked at. So that's the lesson summary right here, all on one page. But it doesn't give you all the practice you need sometimes to understand it all. There's another video on page 3 that's 1 minute and 3 seconds. Here's more on writing the equation given 2 points. Another example right there where it gives you 2 points. It talks about doing that. We can check your answer. All right. But after the lesson summary, that's when you find the more practice problems. A lot of times we need more practice problems just to make sure that we're understanding before we have to do the assignment. And right here, you can do it and actually submit, and it'll tell you if you're right or wrong. That's a nice thing about these practice problems that are built into the lessons, is they'll tell you if they're right or wrong usually. So it says write the equation when a line passes through the point 1, 2, and with a slope of negative 1/3, but write it in standard form. So you'd have to write this in point slope form because you have a point and you have the slope, and then convert it to that standard form. And once you do that, see if it's right. So let's just guess. I don't think this one's right, so I'm going to choose this on purpose. Submit. Oh, excellent. I actually guessed the correct one. Look at there. And then it walks you through exactly how you could have got there. If we'd have chose a different one, it won't let me submit it again. Oh, go to the next one. Okay, now I can go back to the previous and submit again. If we chose the wrong one, it'll say, nope, try again. So it tells you what you need to do. Start with the point slope form. Since that's the two pieces of information you're given, and then convert it. So lots of good practice problems in here. This has 3 practice problems on this page. Then you go to page 5, and there's more practice here. Question 1 of 7. There's 7 different questions here. All right, it gives you lots of practice where you can check to see if you're correct right there in the lesson. All right, let's move on to look at lesson 6. 1.06, comparing functions. Comparing functions. So I'm going to put my paper back up here. Turn this over. Let's look at the other side. Comparing functions. That's an important quality that we need to be able to do. We need to be able to look at functions and tell the difference between them. So to do that, here, I'm going to put some functions up on the screen. All right, so there's 4 functions here on the screen. And when we're comparing functions, most of the time when you're asked to compare functions, the functions are not going to be in the same form. Like right here, we have the equation, right? This is mx plus b. So you have slope-intercept form. Then you have a graph of a different function. Then you have a table of a different function. And then you just have like a little paragraph or a sentence describing the 4th function. So we have 4 different functions here, and it wants us to compare them. So when we compare, we're going to compare based on what information we can pull out of it. Generally, if it's a line, we can compare slopes. All right, we can compare the slope if it's a line. If it's a exponential or quadratic, okay, you're not going to be able to compare slopes on that. But especially if we're comparing lines, slope, we can compare the intercepts, right? The y-intercept, especially. That's generally what we're going to look at on a line, is what is the y-intercepts. So we can say which one has a higher or which one has a lower, or they have the same y-intercept. And then the other thing we can compare is whether it is increasing or decreasing. All right. We can say, well, this line increases, this one decreases. Those are the 3 primary things we would look to compare. So if you're asked to compare things and they're lines, look for those 3 things for your comparison. So let's look back at our ones we had on the screen. Let's look at the slopes first. What is the slope of h of x? That's one of the easiest ones to get. Put it in the chat. What is the slope of h of x? $14. Very good. Mx plus b, the m, whatever the coefficient of the x is, 14 is our slope. Let's look at our graph. I'm going to make this bigger so we can see that a little easier. It looks like it goes through the intercept of -5. So that's 1 point. So if we want to count the slope, it's rise over run, we need to find the next time it goes through an actual point. And it looks like it goes through, I'm guessing it's supposed to go through 5, 1, 1, 5, the point 1, 5. So if the intercept is at -5 and the next point goes through is up here at +5, what is our slope for this graph? So the equation is 10x minus 5. Yeah, y equals 10x. So Abraham put the the whole equation for us. So if it's 10x minus 5, 10 would be the slope because that's our m. Counting the rise of the run, it rises 10 and runs 1. All right, so that is our slope there. We have a slope of 14. Let's see, I actually typed it under there. Slopes. This one's 14. This one's 10. What is the slope of our table? J of x. When x is 1, the equation's 4. When x goes up to 2, it moves up to 12. When it goes to 3, then the y is 20, or j of x. How do we find the slope for the table? And the slope is how much does the equation change every time x goes up 1? Well, in this one, they gave us a nice table where the x does go up 1. So this one has a slope of 8. Very good. So you guys got that in the chat. 8. Our last one just tells us about Steve. He's got a job that pays him $12.25 per hour that he works. How do we get our slope out of that? Per hour is what kind of tells us the key. So per hour. So for every x, it'd be one hour for 12.25. So that's a slope of 12.25. Very good. You guys got that. So if we're comparing slopes, it'd be easy to say which has the smallest slope. Well, that would be j of x. We can see that from our comparison. Which has the largest slope? Which one, if we look at increase or decrease, our slopes will tell us that too, right? All of these are increasing. We do not have a decreasing function. All increase because they're all positive numbers. If there's any negative numbers, those would be decreasing. How about y-intercepts? What's our y-intercept for h of x? -8. Absolutely. It's right there. It's mx plus b. The b is -8. How about on our graph? Graph's an easy one. We can just look and see where does it cross the y-intercept. Where does it cross the y? It crosses the y way down here at -5. -5 is where it's going to cross. See the y-intercept. Where does it cross the y-axis? Well, that's way down here at -5. All right. It's not the x. It's wherever the x value is 0. What is the y value when the x is 0? Well, when the x is 0 right here, the y is -5. So when it says y-intercept, that's quite literally where it intercepts the y. Where does it cross the y? So -5. All right. So where does this cross the y? We don't have when x equals 0. But that's what we need. When x equals 0, you can substitute 0 into the equation, 14 times 0 minus 8, and that gives us -8 because that's when x equals 0. On the graph, we can look and see when x equals 0. This one, we would have to calculate, okay, what if the table went backwards 1? What if we had another space up here and it had the 0? What would the value of j of x be when x equals 0? And that would be our y-intercept. Very good. -4. So since it goes up 8 every time, we got to go backwards, subtract 8. Because if we subtract 1 here and subtract 8, that gives us a -4 as our y-intercept. How about here? When x equals 0. Basically, when Steve works 0 hours, how much money does he make? Yeah, he makes nothing because he gets $12.25 per hour. If the hours are 0, that's how many he makes. No money, absolutely. So that is the y-intercept. So if we compare that, 3 of them are negative. If we look, which one has the greatest y-intercept? Well, f of x does, because 0 is our largest number there. Which one has the smallest y-intercept? That's going to be h of x, because -8 is the smallest number we have on there. So that's what lesson 6 is looking at, comparing functions, and it's generally when they're in different formats. I mean, it's a lot easier if they're all 4 graphs, right, to say, okay, which one has the biggest y-intercept. You can just look at the 4 graphs and see which one crosses the y at the highest point. But generally, in comparing functions, you're not going to have functions that are in the same form. You'll generally have These forms are some combination of these forms. You may not have all four, but a lot of times you do. You have the equation, the graph, the table, and just a sentence or two, a paragraph about it. So, all right. Any questions on comparing functions? Understand what we're looking at? Again, this lesson is going to focus on lines. If we have quadratic equations and other types of equations, we can't compare all of these things. We can compare y-intercepts a lot of times. And increasing, decreasing, we can compare that if it's increasing or decreasing. But you won't have slopes with quadratic equations because the parabola slope changes constantly throughout the thing. Same thing with exponential. It's a constantly changing slope. So on other types of equations other than linear, you're limited on what you can compare. It's a different comparison. So we'll primarily be looking at linear in lesson 6. So, all right, that's the big picture, guys. That's what lessons 5 and 6 are. 5 is about writing equations of a line, either slope, intercept, point slope, or standard. And then lesson 6 is all about being able to compare lines. So that's your lessons. That's your assignments this week. You got the quiz first. Quiz 1.03 is the quiz over our lessons we had last week. And then you have assignments 5 and 6. But that's it. If you have any questions, I'm happy to answer them. Otherwise, go away. Just kidding. This is a 70% or less week, right? From now on, you don't have to attend the rest of the week as long as your grade's over 70%. And so you guys, maybe I'll see some of you tonight for parent-teacher conferences. Maybe not, but have a great week.
3, 2,
1.